Okay, this is number 12 on section 3.2, and I did this in quite a bit of detail, so hopefully you won't have any problems following everything, all the little steps. So this is my function f of x equals x to the 4/5 power. Okay, and the directions where they wanted you to, they say that the function fails to be differentiable at x equals 0. Tell whether the problem is a corner, a cusp, or a vertical tangent, or a discontinuity. Okay, so number 12 here, we can remember that the definition of the derivative, f prime at a point A is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. And in this case, we're talking about an issue at x equals 0, so my a will be 0. So what I'm going to do is I'm going to check the left-hand derivative and the right-hand derivative to see what happens. All right. First of all, I know I don't have any discontinuity, so I know that this function is actually continuous. I can put any value in here, even 0, 0 to the 4/5 is 0. So it's defined, so it's not a discontinuity, so I don't have to worry about that. So I'm going to check the left and right-hand derivatives and see if I've got a corner. That means they're both equal to numbers that are different, or a cusp, which means one goes to infinity, one goes to negative infinity, or vice versa. Or a vertical tangent, that means they both the left and the right go to either positive infinity or they both go to negative infinity. So let's see what we've got here. So here's the left-hand derivative, and this is my function. So again, I just wrote the derivative. This is the left-hand derivative as x approaches 0 from the negative direction. And then my point A is going to be 0, so I put A in here. And this is nice because 0 plus h is just h, so I'm just going to have to put h in the function. So I go back up here, and this is my x to the 4/5, so if I put h, 0 plus h, which is h into that, I just get h to the 4/5. And minus f of 0, I just put 0 in there, and I get 0 to the 4/5. Okay. Should have been an orange 0, sorry about that. Fix that, okay. That's 0 to the 4/5 over h. So that's just 0, so that goes away anyway. So I got h to the 4/5 over h, and then if I bring this to the bottom, this would be h to the negative 4/5. So h times h to the negative 4/5, which means I would add, so that'd be h to the 5/5 minus 4/5 is 1/5. So I can put this down the bottom. Okay, I hope that doesn't confuse you by skipping that step. All right, so I put this down the bottom, and that ends up being h to the 1/5. All right, does everybody get that? This would be h to the minus 4/5. Okay. So we've got that. Okay, now I'm going to use a very small approach. As I approach 0 from the negative direction, I'm going to have a number very, very small, but just to the left of 0, which might be negative 0.000001 to the 1/5. See what happens. Now I can break this up into negative 1 times this, both to the 1/5 power, and negative 1 to the 1/5 is just a negative, because I'm raising it to an odd power. In other words, I take the 5th root of negative 1, I get negative 1 to the first power is negative 1, so that's a negative sign. So I can put that out front. And then I've got this. Now remember, we can change the very, very, very small number to 1 over infinity, because that's also a small number. And then I can really raise 1 to the 1/5 and infinity to the 1/5, and I get 1 over infinity. So this part here becomes infinity, and then I have a negative in front, so that's negative infinity. So try to follow all that. Hopefully it makes sense. I did skip a little step over here. I put in some other problems, so you'll see those steps carried out. Okay. And again, the right-hand derivative, we're going to check the right-hand derivative, and we'll do the same thing. This is my derivative formula, f of a plus h minus f of a over h, and I'm going to put 0 in for the a, because I'm looking at when x equals 0. And then I substitute this into the function, that's h to the 4/5 minus 0 to the 4/5, which is just h to the 4/5. And again, if I bring this h down, that's going to be h to the negative 4/5, and if I add 5/5 to negative 4/5, or 5/5 minus 4/5, I get 1/5. So I hope you can follow that. Okay. Probably a step I should have put in, at least the first time. So we can see that. And then again, I'll use my very small approach, except, sorry about that. That should be positive. We fix that now. Because as h approaches 0 from the positive direction, it's just going to be a number just to the right of 0, so positive 0.00001. If I raise that to the 1/5, again, I can say this is, and I kind of carried this step out that I didn't do over here. I wrote this as 1 to the 1/5 over infinity to the 1/5, but that's just going to be 1, and that's going to be infinity, so this is what we have. 1 over 1 over infinity is just infinity, so that's a positive. So notice how my left-hand derivative goes to negative infinity, and my right-hand derivative goes to positive infinity. So if that's the case, by the rules we had at the beginning of section 3.2, f of x has a cusp at x equals 0. So it's a cusp. Okay? Negative infinity, positive infinity, cusp. Okay? Hope that makes sense.